So today I am going to discuss on the topic projection on inclined plane. Okay, suppose we have an inclined plane making an angle of alpha with the ground. Okay, now what do? We project a body with an initial speed u, and the direction of the speed makes an angle of theta with the inclined plane. Remember the that theta is the angle which the speed makes with the inclined plane, not with the ground. Okay, now while solving any problem related to projection on inclined plane, what we do is that we define two axes, x-axis and y-axis. In this case, in case of an inclined plane, the x-axis must be taken along the inclined plane and y-axis must be taken perpendicular to the inclined plane. Okay, and one more point which I would like to tell is that you must take the point of projection as the origin. The point of projection must be taken as the origin. Okay, now let us proceed and calculate the time of flight. Okay, before calculating anything, what I will do is that I will analyze the motions for x and y directions. Okay, considering for x direction, if I denote the initial speed in the x direction as ux, then it will be equal to I have to resolve it into components. See, this is u, this is the x-axis and this is the y-axis, and the initial speed makes an angle of theta with the x-axis. So ux can be written as u cos theta. Okay, in a similar way, if I consider for y direction, then uy can be written as u sin theta. I have done nothing but I have resolved the initial speed into two components, one along the x direction and one along the y direction. Okay, now similarly I will resolve the acceleration into two components. We all know that gravity acts vertically downwards. Gravity will be acting like this. Now if this angle is alpha and this angle is 90, then this angle is 90 minus alpha. So if I draw a perpendicular, now if I draw a perpendicular, then again if this angle is 90 minus alpha, then this angle will be again alpha. Okay, so basically I can resolve the gravity into two components, one along this direction or the direction perpendicular to the inclined plane, and another along this direction or along the inclined plane. This time perpendicular to the inclined plane will be g cos alpha, and parallel to the inclined plane will be g sin alpha. Okay, so in this way I can write ax is equal to minus of g sin alpha and ay is equal to minus of g cos alpha. Remember that I have written minus here because I am taking the upward direction, or this direction is positive and gravity is acting, or the component of gravity is acting in this direction. So I have written here minus g sin alpha. In a similar way, I have taken the upward direction as positive. Okay, but one component of gravity is along this direction. So I have written it as minus g cos alpha. Now if I have to calculate, suppose I have to calculate the time of flight. Okay, if I have to calculate the time of flight, then we know that time of flight will be the time after which it will again strike the inclined plane. Okay, so for time of flight, what I can do is I can put the displacement along y direction as 0. See, this is the y direction. Again, if it hits the inclined plane, then the displacement along y direction will be 0. So first I will write the formula for displacement. This will be equal to uy into t plus half of ay into t square. Now what I can do is I can put y displacement as 0, because for time of flight y displacement is 0. So here we go, and for that particular time we can denote the time of flight as by t. So this is uy into t plus half of ay into t square, which gives me that either t is equal to 0 or t is equal to minus 2 times of ui by ay. T is equal to 0 gives the initial time when the body is projected, and this gives me the time of flight. Okay, if I would like to calculate it further, then what I can do is I can put the values of uy and ay. Remember that although it looks like the time of flight is negative, but it won't be negative. You just put the values of uy and ay and see. Uy is u sine theta, and ay is minus g cos alpha. Okay, so the time of flight comes out to be 2u sine theta by g cos alpha, right? Okay,